Hello, guys. Welcome to Ramtar Solutions. Welcome to your work, energy, and power examination prep. Today, the question paper that we are looking at is the Gauteng Provinces examination of September 2024. So, without any waste of time, let's get into it. An ice skater of mass 53 kilograms moves on a frictionless surface AB with a velocity of 6 meters per second. So frictionless, AB is frictionless. Okay, then we might be expecting our velocity to be constant at AB. And then slides up a rough inclined surface BC. Rough, so it means we are experiencing or we are expecting a frictional force on the path BC. Okay, until coming to a stop at point C. So cool. V at A will be equal to V at B, which is equal to 6 meters per second. And then speed at C is 0 meters per second. So until coming to a stop at point C, 1.5 meters above the horizontal. So HSC is 1.5 meters. Cool. The angle between the incline and the horizontal is theta. All right, cool. 5.1, state the work energy theorem in words. So remember, guys, we have 13 minutes to complete this question. 1 mark, 1 minute. Work energy theorem says the net work done on an object is equal to the object's change in kinetic energy. Okay. Cool. Now 5.2. 5.2, draw a labeled free body diagram showing all the forces acting on the skater at point C. All the forces acting on the skater at point C. So now we are going to look at the path BC. Okay, we are going to look at the path BC. Gravity is always perpendicular to Earth, and the normal force is perpendicular to the surface, and this skater will experience friction. So this is normal force, and this is the force of gravity, and this is friction. Alternatively, you can draw a free body diagram that looks like this, where you say this is your vertical component of gravity, this is your normal force, and then this is your horizontal component of gravity, and this is your friction. You can draw this as well. Okay, it is still okay. All right. 5.3, explain the term non-conservative force. So non-conservative force is the force whose net work done is non-zero and it depends on the path taken. Okay, however, you guys use this one, force for which the net work done is dependent on path taken. All right, force for which the work done is dependent on the path taken. On the path taken. But remember, you can also say force for which the net work done is non-zero and depends on path taken. Okay, cool. 5.4, calculate. 5.4 says to you, calculate. What does it say? It says to you, calculate the angle theta of the slope if the skater experiences a frictional force of 20 newtons. Ooh, if the skater experiences a frictional force of 20 newtons while skating up the slope. All right, no worries. So 5.4, what we are going to do now, 5.4 is this. We have a free body diagram, as you can see. Now, I, for one, would prefer that we use work done by a non-conservative force. That formula, especially when they say you have friction, will always work wonders for you. Okay? It is equal to change in potential energy plus change in kinetic energy. Therefore, you will say you have F delta X cos, let me see what was the angle there, theta. So friction uh, opposes motion. So let me immediately say 180 degrees. And then this is mgh at point C minus point B. Okay. Minus mgh at point B plus half mv point C squared minus half mv point B squared. So they said the frictional force is 20 newtons. But hold on, the frictional force is 20 newtons. There's something that I want to show you. The delta x is not given. Can you guys see that? The delta x is not given here, right? The delta x is not given. So we know sine theta is equal to opposite over hypotenuse. So this is, remember, we're going to call this part here delta x. So this will be 1.5 over delta x. What does it mean? It means delta x will be 1.5 over sine theta. Okay, that's what it means. Okay, now let's go. Now, where there's delta x, we're gonna write, oops, this is too big. So this is 1.5 over sine theta. Let me just say minus because it was 180 degrees, cos 180 degrees, all right? Equals, what was the mass of the object? It was 53. Gravitational acceleration constant is 9.8. And then the height, it was 1.5. Height at point B was 0. So let me not worry. The object comes to rest at point C. So let me not worry about this. And then mass is 53. At point B, the speed was 6 meters per second, isn't it? Good. Now let's see what we have. 20 times 1,5. 30. 20 times 1,5, it's 30. So this is minus 30 over sine theta equals 53 times 9,8 times 1,5. This is 7. This is 779,1 minus 0,5 times 53. Let me just say 18 times 53. Right? No. Yeah, 18 times 53, it will be 959. So we have minus 30 over sine theta equals 950, 779,1 minus 951. Let's see. Let's see, this then becomes 100 is equal to negative 174,9. All right. Now, sine theta will be 30 over 174,9 will be equal to sine theta. So if you do maths, this will be 30 sine inverse of 30 over 174.9 equals theta. So what is theta? Let's see. 30 over 174.9. So what is this? Therefore, theta is 9.88 degrees. Okay, theta is 9.88 degrees. And this is how you solve this question. Remember, guys, some of the steps are not really necessary. If you are quick and you are sure that you're not going to make mistakes, you can skip some of them, right? You can skip some of them only if you are sure that you will not make mistakes. So, as usual, we were done with this question in like 10 minutes. We saved about 3 minutes. Right. So, this is it, guys. And this is how you attempt your exam. All right. That's how you manage it. Bye bye.